Welcome back. Now we will begin on the rather large topic of functions. This talk will deal with some introductory concepts and a not so introductory concept of pass by reference. First, why we use functions. You may have already started to feel like these are necessary in your programming, so you might already have some ideas. The simple answer is that functions are one way that we can make our programming modular. That's the key word. It's something that we like in all kinds of engineering, not just programming, but other kinds of engineering. It's nice to have modular nature to the things we work with. Some of the advantages that they give us in programming, they allow a divide and conquer approach. So you can think of this really big project you're working on. If you can identify certain clear pieces that you have to solve and work on, you can solve each of those one at a time and then hook them all together, and hopefully that will solve the problem. When you do this approach, debugging becomes a lot easier. You can take one piece of the code, one function that has a certain task, test it thoroughly, make sure it works under all possible circumstances, and then start using it in your program or programs, which is one of the natural things about functions, or having modular programs, I should say. If your programming is truly modular, then you ought to be able to grab it from one program and just dump it into another program with very little effort. There's a lot to that, though. Making that realizing that is actually a fairly advanced issue, but you'll quickly see the utility of functions. If you've already got a certain hunk of code that does a certain job, it's very easy to pull that into some other program. Functions are just one part of this topic, but it's the starting point. If you have a very modularized process, there's clear pieces that have to be solved, and some of them might be solvable at the same time, so that one programmer can work on one part of the program, another programmer can work on the other part. All they need to do is talk about their interfacing information, who's responsible for what. But as far as the inner workings of what they're all doing, they don't need to share that as much with each other, and that allows code to be developed much more rapidly. If you write in a modular way using functions, your code will be more organized. That's better for you and for others. If you write a code that's one great big long main, and it's all intertwined, it's very hard to come back and look at that a month later and figure out what you actually did. If you write it as using functions in a very organized way, you can come back years later and very quickly understand what it was you were doing, and certainly that's going to be true of other people who look at your programs, try to understand what it is, to try to maybe update your code. If you've done it properly, then they should be able to quickly understand how the code is organized and make the changes. If you've not followed a clear modular approach, it's going to be a lot more difficult for them to make the updates. Surprisingly, you might find that code can actually be shorter. For these little projects we're doing at first in this class, the modular stuff will actually add some extra lines. There's a little bit of overhead involved with functions and later with objects. But when you get far enough into it, it actually becomes a process that shortens the code. Imagine you've got a 100-line piece of computer algorithm, something that's just some kind of math operation. It takes about 100 lines of code. Let's say there's 5 places in your main where you need to use that or something very similar to that. That's 500 lines of code. If you take those 500 lines of code, just take one of them, put it into a function. Maybe there's a few extra lines to make the function work, so it's 105 lines now. But then you call that function multiple times, once every spot where it appeared. Instead of 500 lines of code, maybe you have 120 lines of code or something like that. So you've greatly shrunk down the actual amount of code by taking that repeated operation and putting it into a function and then just calling the function whenever it's needed. So those are some of the advantages. There are new issues involved when we start getting into functions. One thing is, if you're going to realize these advantages, you really need to document your work very well. You need good comments. It needs to be very clear. When does this function operate? What does it need to work right? What does it return? And under what circumstances does it fail? Those things all need to be documented if you're going to be able to quickly grab that function and use it elsewhere. If the person using it has to actually dig through your function and figure out all the details of how it works and test it themselves, then you really haven't saved all that much time. So a thorough documentation of your work is important. Maybe not quite so important now, at least with our compiler, but in the past, certainly, you could have trouble with data passing. We're talking about taking information, say, from the main function, sending some of that information to your function, so it can, this new function, so it can do its job, crunch some numbers or whatever, and return an answer or answers. Now, to do that, there's some data passing going on, and that data has to make it into the function. And it's possible in some programming languages for that process to fail, and the data doesn't actually get into the function the way it's supposed to. But the program keeps running, and it keeps thinking it's working. That's a real terrible situation to be in, because that's one of those situations where your program runs, everything seems fine, but it gives garbage as the answer. That can be a hard error to track down. We use a strongly typed language, and we have to declare all of our function arguments explicitly. We have to make it very clear what information is being sent to the functions. And if there's any kind of a data type mismatch, our compiler will flag that, and that's a great thing. It might be a pain. Getting functions to work can be a little bit of trouble at first, but it's really nice in the long run because it prevents you from accidentally getting your information garbled when it gets sent down to the function, or at least that's the idea. A little bit about the basic syntax, how it works. I'll show you this on the compiler, but on the editor, but a few basic points I want to make sure are clear. The function prototype is something you need. That is a signal to the compiler that, hey, I've got this function coming. This is its name. This is its information that you're going to be sending to it, just the type. You don't actually need the names of the data you're sending, just the type of data. So maybe I've got a function and it needs 3 floats and an int, something like that, and some character data or whatever. You tell the compiler in the prototype what data is being sent to this function, and if it has a value that it's returning back, an object that it's sending back, you tell it the type that it's returning. Something about our functions in C++, they're intended to work somewhat like algebra functions. In algebra, you say y equals f of x. That could actually be a valid C++ command. If you had a function called f, then the command y equals f of x would be valid, where the of x is in parentheses. So f, open parenthesis, x, close parenthesis. That, just like in algebra. You could do that in C++. You're sending x to the f function, and it's returning an answer. Now, C++ functions are slightly different than algebra functions in that they can return one answer most of the time, but they have the option to be a void function. Void isn't really a type. Void is a lack of type. So a void function is a function that doesn't actually return anything. That breaks the rule of what algebra taught you. Algebra taught you that if you put in a valid number that's in the domain of the function, it returns exactly one value from its range. So for every domain value that you send it, one range value comes out. Functions in C++ are almost the same. You send stuff to it, it returns exactly one thing, or 0 things is an option. You can choose not to return anything. So that's a little bit of a twist. That also brings up the question of how do you return multiple things from a function if functions are only allowed to have one output, and I'll show you that at the end of this talk. The other thing that people often get confused about, they're used to having everything inside their curly brackets. We've got a set of curly brackets that have been defining all of our commands in the main function. But we're going to break from that now. The main function is a function. Its commands are enclosed in curly brackets. You've got the main function here, and now underneath it, you can have a totally separate program. That's kind of what it's like. A function is its own little micro program. It's got its own variables. It's got its own set of curly brackets, and all its commands go inside those curly brackets and outside the curly brackets for main. So the function you write is going to be totally outside of your main. Don't try to put it inside the curly brackets that belong to main. You'll get it all tangled up. It won't compile. You need to have the sets of curly brackets for the main be separate from the curly brackets for the function. I mentioned a second ago, and I want to repeat this, that functions have their own variables. The names might be the same. You might have a variable called x in main and another variable called x in your function. Unless you do something special about that, those are 2 separate variables, both with the name x. That can be a little confusing, but you just get used to it as a programmer. You know that functions have their own variables, unless you do something to share them, which usually you don't want to. The idea of modularity is that these are separate programs that are hooked together with a well-defined interface. if they had all the same variables, that actually breaks down the modularity, and your code is not as good. So try to, well, you'll get used to it. If you have a variable in your function, you want to print it, you need to print it in the function or somehow send it back to the main for the main to print, or do calculations with it. You can't just use the function variables anywhere in the main, or you can't use main variables in the function unless they're connected through the argument list, which I'll show you in a minute. At the end here, I'll indicate the difference between pass by value and pass by reference. You're probably going to start with pass by value. That's the simplest thing to do. You're sending, think of that as sending the data to the function. The main has its variables. It's got numbers in those variables. When I call on my function, I ship off the numbers to another set of variables that receives those numbers. And those variables are the ones, those receiving variables are the ones in the function. They receive the data from the main, and then the function does its calculations, and it ships an answer back to the main through its one return value. That's a typical approach for regular functions. We also have the option of pass by reference, however, and I'll explain that when we get there. But the idea there is you can actually send the memory address of data rather than the data itself, and that allows you to actually effectively change the inputs to a function. Think about the function square root of x. Y equals square root of x is a function. We didn't write it, but it's still a function like the ones we're going to write. When you send x off to the square root function, you expect it to be unaffected. Y equals square root of x could be an example of pass by value. X is not affected when there's no way the square root function can ever change x. It sends an answer back, which happens to be the square root of what number was stored in x, but x is unaffected by that function. And that's kind of what you expect out of functions most of the time. It's a pretty special, it would seem a pretty special case to send numbers off to a function expecting them to be changed by the function. But actually that's a normal thing in C and C++. It's the only way to get multiple outputs from a function. So I'll show you that in just a minute. First, I want to just whip up an example here, a real simple function from a blank template. I say this shows a basic function. So I put a comment in here at the top, function prototype. That's after my include and my using namespace command, but it's before my main. Up here, before my main, I'm going to put in a function prototype. And let's say that my function returns an integer, so I'm going to put int there. That int could be float. If my function was a square root function, that would probably want to be float. It returns a floating point. But this is the type of data that the function is going to return, and I'm saying int in this case. I'm going to call the function myFunction with an underscore, and then an open parenthesis, and I need a type of data. And let's say I'm going to send it float data. I could just say float and be done with it, but I'm going to go ahead and say float x. The variable name is actually optional. All you need is the variable type in that slot. The functions work by, and there could be multiple variables there. I could say float, float, float. If I wanted to send 3 floating point values, x, y, z, to my function, I could just say float, comma, float, comma, float. Put the variable name or names in there just because it's easier to follow. All right, so I've got a function called myFunction. Now, in my main, I'm going to have a variable that's floating point, and it's a. And I'm going to say a is 5.6, and then I'm going to call on my function. I'm not going to have any sort of an assignment statement or anything. I'm just putting the name of the function, my function, open parenthesis, a. And what I'm doing is sending a to the function called my function. And that's all I'm going to do right now in my main. And my main is done. I go down here where we've never gone before. We've always had to stay inside these curly brackets, but now we're going below the curly brackets, and I'm going to have the function. And it's easiest if you just copy the prototype like I did here. I can just copy it down here. The big difference is that the prototype has a semicolon. That ends the prototype right there. But I have to get rid of this semicolon because now I'm actually defining the function. So I don't have a semicolon at the end. I open a curly bracket, and I'll go ahead and close the curly bracket. This new set of curly brackets is another little program, and it's going to contain all the commands that I want my function to have. And I'm only going to have two commands. I'm going to have a cout command, and it's going to print the message, you sent me, and $$ x, $end_l. I just wanted to see if the function can find out what number was sent to it. So I'm going to print that to the screen and then return 0. The 0 is an integer. If I had a void function, I wouldn't put anything here, but I declared my function to be int. So I'm going to return an integer of 0 always. I could have that be any integer value, but for now I'm not using that feature of the function. All right, let's see if that works. You sent me 5.6. Now, let's think about that. That's kind of interesting that it said it knew 5.6 was x, because up here in the main it was called a. I chose different names there to emphasize that those are different variables. Even if I had picked x up here, it doesn't matter. They're different variables. They could have the same name or not. It doesn't matter. The value that was stored in a was 5.6, and this command shipped that number off to the function, and then the function could do whatever it wanted with that number in this other variable called x, which is a function variable. Now let's say up here in main, I wanted to do that same thing. Cout x equals x. So I'm going to print x to the screen, but now I'm up in the main. Try to compile this, and it gives me a message. It says, I've never heard of x, is probably what it's saying. Yeah, x undeclared, first use of this function. So it's never heard of x. I don't know what x is. I can't print it. That's because x is not a variable in the main. This command was an error because there is no x in main. The only main function variable is a. I could print x down here like I did. I couldn't print a down here because likewise a is not a function variable. A is a main program variable, and they're only seen inside their own little set of curly brackets. So the interface between the two is this list. This float x defines how the two parts of the program talk to each other, and also this int could be used to send an answer back. So if I wanted to have another variable in my main, call it c, I could have said c equals my function a, and then I'll print c to the screen after I call my function. For my return command, just so we see some number other than 0, I'm going to return 6. All right, again, it says you sent me 5.6, and then it says c equals 6. So that's a way that the function was able to talk back to the main through this int value. That's the return value of the function. You can only have at most one of those. I said you could have 0 of those, so it's either 0 or one of those. You can send an object back through that mechanism, and you do it with this return command. The return tells you what you're sending back to the place where it called. Note that I'm now using my function inside of another statement. That's technically an assignment statement, and just like the square root function, I could do things like, if I wanted to double the answer, 2 times my function, now instead of saying c equals 6, it says c equals 12. That's because the function returned 6, which substituted in here after the function was done, and double 6 is 12. So c was assigned to be 12. So that function call works just like the way you might have used square root function earlier in the course. It can go in as part of an assignment statement. It can be used in a cout command. It can be used in other function calls even. They can be nested. So there's all kinds of things you can do with this. That was just the basic syntax. Now I want to go to a website example. This is a use of 2 functions. The example uses 2 functions for calculating information about trapezoid. So I've got 2 prototypes. The first prototype is for a function called trapezoid area. It returns a float. In its argument list, there's 3 floats, base, height 1, and height 2. Just as a reminder, the formula for area of a trapezoid is base times average height. So you send 2 heights, you send the base, and it returns base times average height. And then trapezoid perimeter is also a function in here that I have using the same 3 numbers, base, height 1, height 2, are the arguments to that function. So it's 3 floats. I could have just said float, float, float here, but I went ahead and put in the names there because that seems to make the prototype a little more meaningful. It's a little easier to look at when you see that. And you know that the base is first and not last. The order of those 3 is very important. You can't just put them in any order you want at any time. You can have them in any order when you define them, but then you've got to follow that order in future uses of the function. Each function returns a float also. So these are all real numbers for these 2 examples. That makes sense for what I'm doing. Now in the main, I do have a variable called base, but then my heights I called h1 and h2. Those are different names than what they're used in the function. I called it height 1 and height 2 in the function, but the names can be different. I happen to use the same name base in the functions and in the main, but again, those are different variables even though they have the same name. They're not seen by each other. If you change base in main, it doesn't change the base directly anyway in the function. That only happens when you call on the function, when you send that value through the argument list. That's the only way to change the function values when you call the function. Or that's the way, I better be careful here. There's other ways to do what we're talking about, but for now that's the only way. All right, I asked the user to enter a base and 2 heights, and I have a little comment here that, and this is one advantage I kind of forgot to mention about functions. I said it makes the code more organized, and this is an example of that. Imagine that the particular math we're doing was a fairly long, might even only be, say, 10 lines of code to do some number crunching. Well, if you put that into a function, you take those 10 lines out of your main or out of one part of your function, you put it away out of sight, and you replace it with a nice meaningful phrase like find velocity or calculate time. And it's a meaningful set of words rather than some equations. And that makes your code a lot easier to look at. It allows you to look at the higher level stuff and not get so down into the nitty-gritty of the calculations. And that makes your code a lot more organized. And maybe I could have called this function find trapezoid area instead of trapezoid area, but you get the idea. This is calculating the trapezoid area. I send it base, height 1, and height 2. Note that here I'm inside the main. I do not list the types. That's already taken care of in the function prototype. All I do is list my 3 variables, base, h1, h2, separated by commas. Those are arguments to the function. They're enclosed in parentheses, just like any function call. You use regular parentheses. Sends that to the trapezoid area function, and it returns an area. I do the exact same thing to get the perimeter. Base, height 1, height 2 are sent to the trapezoid perimeter function, and then I print everything to the screen. I echo the input and print the answers. You don't see any computation in the main. It's all been moved to the functions. All right, here's the end of the main. Return, exit success, close curly bracket. And now I get to, after that, I get to the 2 functions. They're very simple functions. The first one only has a single line. It takes 3 floats, base, height 1, height 2, and to calculate base times average height, that's this little bit of math here. It's base times open parenthesis, height 1 plus height 2, close parenthesis, divide by 2. And that's actually embedded in my return statement. I say return, and then what do I return? Well, I return the results of this math. So with this little trick, you can actually do your, if it's just a single formula you're doing, you can make it part of a return command. You don't even need a special variable inside the function if it's this simple of a function. And that's not uncommon to do that. My second function is a little more complicated, however. I have an intermediate variable diagonal. I decided that would be a little helpful. That float diagonal is a function variable only. Now, an interesting thing about that variable is it's only there as long as the function's running. You call on the function, you jump down there, you go through the function returns, diagonal is gone. All right, it should be just out of memory totally. It's only used while the function's running. But while the function's running, I want to calculate the diagonal. The trapezoid has 2 regular lines that are parallel to one of the coordinate axes, and then a third line or fourth line that is at a diagonal usually, And calculating the length of that diagonal requires that I use the distance formula. I've got base squared times the square of the height difference. So that's base times base plus height 2 minus height 1 times height 2 minus height 1. And that sum of squares goes to the square root function. So what I'm doing is the distance formula. If you look up at the top of my program, you'll see that I did include CMath at the very top so that I'd have access to the square root function. And then, since this is perimeter, what I return is base plus height 1 plus height 2 plus diagonal. The length of those four sides adds up to the perimeter. So let's run the program. Enter the base of the trapezoid. Let's say it's 10. The height 1 is 15. Height 2 is 20. It says for a trapezoid with base 10 and heights 15 and 20, the area is 175 and the perimeter is 56.18. So that sounds about right. Calculated those numbers. That's pretty good. That's a real good use of functions right there. It's very common. But you quickly will become dissatisfied with that after you program for a while. Let's say, for instance, I wanted a single function that did both. Well, I'm in trouble. Or maybe I'm only calculating one thing, but I also want to have a logical variable, a Boolean variable, true or false, that tells me whether it worked or not. Even that simple situation is not allowed with what I've shown you so far. You send off a number, and you expect the number to come back with the answer, or if it didn't come back with the answer, you'd like to know that it failed. And rather than trying to do that all with one single float variable, you really prefer to have a flag or some sort of indication that it failed. So even in the simplest function that only calculates one number, you have a strong reason to want a second piece of information from that function, which is did it work or not. And so now you need two things from the function, but that seems to be a problem because functions can only return one object. Now when we get to objects, we'll learn how we could combine those together to make one clever object that contains both pieces of information, but that's way more advanced than what we want to do right now. There's a much simpler C solution, not C++, but a C solution for doing this. People have been doing this for a long time. They've always wanted their functions to return multiple values, and so how do you get around this limitation that functions return exactly one thing? And that's where we want to switch to pass by reference, which has other advantages, but right now the main advantage is it's going to allow us to return more than one thing. So I have an improvement on this program. This is the same computation. It does everything the same, but it's now just one function. And instead of having any outputs, I'm actually going to make my function void. Normally what I like to put in that spot is bool. I like to have a Boolean value, true or false, true if it worked, false if it failed. That's a good way for me to do computation. That way you can put that inside an if statement or a while loop, and the output can decide what happens next. But also it needs to return its answer. To give the answer back, we use pass by reference rather than pass by value. The change will appear to be very subtle, but the difference is important. The name of my function now, the single function, is trapezoid area and perimeter. It calculates two numbers instead of just one. It takes as its input the same three things: float base, float height 1, float height 2. I'm looking at the prototype right now, not the function call. And then I add two more things to this list. There's actually 5 items in the list rather than 3. These last two are going to be the outputs from the function, but they're technically not. They're actually 2 more inputs to the function: float ampersand area and float ampersand perimeter. That ampersand, that's a shift 7 on the keyboard, could be read address of. So that's the address of a float. I'm sending the address of a float that contains the area data and the address of a float that's going to point to the perimeter data or have the location for the perimeter data. Think of that as a memory address that you're sending. Now functions are forbidden from changing their inputs, but the input is actually the memory address. The input is not the data. It might sound like semantics, but that's the way to look at it. It's the easiest way to see it. You're sending the memory address. As long as you don't change the memory address, you're welcome to change what's at that address. And so in that way, the function is able to change the area data and the perimeter data. That's good because right now there's none in there anyway, but this would be a way you could send a number to a function and have the function change that value and return the new value still in that number, in that variable, by passing the memory address. This is called pass by reference rather than pass by value. The first three were passed by value because there's no ampersand. The other two are passed by reference because of the ampersand. That's all it takes to make the difference. Now when I do my program, I have the same variables: base, height 1, height 2, area, and perimeter. I ask the user for the three numbers just like before, but now I don't have an assignment statement here anymore like I did before. There's no equal sign in this expression. I just have the function name. That's appropriate for a void function. It doesn't return anything, so I can't use it in an assignment statement. And then for my arguments, I have base, height 1, height 2, area, and perimeter. Now, these values have not been assigned. They've been declared. I've declared that I have an area and a perimeter, but I didn't put anything into there, so presumably there's some kind of garbage in those spots. Notice there's no ampersand there either. When I use this command inside the main, you actually can't tell which ones are passed by reference and which ones are passed by value. You just have to know that. You can look at the function prototype or the function declaration to tell which is which. I have that single call, and then magically, now suddenly my main knows what the area and the perimeter are. And I can print it to the screen after I do the function call. So we're kind of back to that basic theme I said of computation. You've got input, you've got computation, you've got output, and right now I'm sending the computation off. The middle step, I'm just shipping it off to a function. It does the computation and returns the answers. Let's get down to the function declaration. This is after the main. It's just a copy of my prototype, the only difference being that I don't have a semicolon. Prototype has a semicolon at the end of it. This does not. I again have the ampersands, float ampersand area, float ampersand perimeter. I do have, by the way, I have to have the names here. The names when I declare the function are important because that's used inside the function itself. The only place where the names are optional is back up in the prototype. All right, so I come down to the actual function. I've got a set of curly brackets to enclose all the commands. Calculating the area takes a single command. There's no ampersand or anything special here. I just say area equals. And suddenly I'm changing the area, and that answer will get sent back to the main. Normally, if I was to try to change the base in here, it wouldn't work. It would have a temporary effect inside the function, but it would not have a permanent effect. Any changes I make to base inside the function are not going to get passed back to the main. But when I make a change to area inside this function, it is going to get passed back to main because I actually use pass by reference, not pass by value. Calculate the diagonal just like I did before. Calculate the perimeter. That's going to get sent back to main because I'm using the memory address that was sent to me to store data in the place where the main expects it to be. All right, there's really only one perimeter in this program. There's one area and one perimeter. Unlike the base, height 1, height 2, there's separate variables up in the main for those. But for this case of diagonal and of area and perimeter, those are main program variables, and the function just happens to know where they're located and can therefore change what's stored in those variables. I end with a return statement. There's no number or anything there because it's a void function, just plain old return. Hit F9 to run the program. 10 for the base. Let's try something different. 20 for the height, 25 for the second height. It says trapezoid base 10, heights 20 and 25. The area is 225, and the perimeter is 66.18. So it worked, no errors, and I was able to use one function to return two things. That last bit's pretty advanced. I encourage you, when you first start using functions, just play with the basics, the pass by value. Later, when you realize you want to return multiple things from a function, then you can start playing with pass by reference. But for beginners, just write a few functions, make sure you can get them to run. Real basic stuff. Don't try to do it all at once. You might take a few of the examples from the book. There's some function problems. Get those to run. Make sure you can run a few of the book examples so you can understand how it's all fitting together. It's not especially hard, but at first it's going to seem a little odd. So that's it for now. Thank you.